Hi folks, welcome to Algebra 2 Common Core. Today we're going to talk about solving exponential equations using a method that deals with the exponents. So the equations that we're going to be looking at will have either fractional or negative exponents or possibly exponents that are fractions and negative. So our first step in solving most equations is going to be to isolate the variable. We want to move all other terms to the other side of the equation so that the variable is by itself. Now once the variable is by itself, when we look at the variable, we will see that the variable has an exponent. The exponent can be negative, it can be fractional. We want to know what the value of x is. So since we want to know what the value of x is, we're going to have to undo the exponent that is there. Well, one way of undoing exponents is to raise both sides of the equation to the reciprocal exponent. When we raise both sides of the equation to the reciprocal exponent, that will allow us to get the x by itself with an exponent of 1. To finish up, we want to then solve for the variable if it isn't already by itself. So let's go ahead and try some examples today. For our first exercise, let's solve the equation 3x to the negative 1/2 is equal to 6. Now remember, our goal is to find the value for x that is a solution to this equation. Find the value of x that will make both sides of the equation equal to each other. So when I look at this, I see that first of all, I have a variable x, and the exponent on that variable is negative 1/2. The 3 that's in front of this is the coefficient. So I want to eliminate that coefficient, and to do that I'll just divide both sides of the equation by that coefficient 3. So that now gives me x to the negative 1/2 is equal to 2. For the next step, because I want to get my variable to the first power, I need to raise this side of the equation to the reciprocal exponent. So the reciprocal of negative 1/2 is negative 2. Now if you think about that, it goes right along with our rules of exponents. So I'm starting with x to the negative 1/2. I want to raise this exponential to a power so that my result will be x to the first power. So because when I'm raising a power to a power, I multiply the exponents, x to the negative 1/2 raised to the negative 2, I'll multiply those exponents together, and that's going to give me x to the first power. But if on the left I've raised this side to the negative 2 power, I have to do the same thing to the right side of the equation. So I'm going to say, let's take that 2 and also raise it to the negative 2 power. So I'm raising both sides to the reciprocal exponent. Now let's think about what 2 to the negative 2 means. A negative exponent means that I'm going to take the reciprocal, so I'm going to put 2 to the second power in the denominator. So that tells me that x must be equal to 1/4. Now a good way to check this would be to substitute this in for x and make sure that it works. So I'm going to do one check by hand, but the rest we're going to do using our calculator. So for my check, I'm going to say let's do 3, my original equation, multiplied by 1/4, and the 1/4 is going to be raised to the negative 1/2 power. And I want to know, does that equal the solution 6? So let's go ahead and raise my exponent first of all. So never do multiplication before the exponent. Because this exponent is negative, that means that I'm going to take the reciprocal of the base, so I'm going to get a 4, and change the exponent to positive. So 4 to the 1/2 power. Well, this is just 3 times 4 to the 1/2 means the square root of 4, but the square root of 4 is 2, so 3 times 2 tells me that my answer is equal to 6, so the solution for this equation is x equals 1/4. So the important part of this problem is raising that exponential to the reciprocal exponent. And if I raise the exponential to the reciprocal exponent, I need to raise whatever's on the right side of the equation to that very same exponent. So let's go ahead to exercise number 2, where we see that we have the equation 2x to the negative 1/3 is equal to 6. This looks very similar to the last equation. I want to isolate the x, so I have to divide both sides of the equation by 2. So I now have x to the negative negative 1/3 is equal to 6 divided by 2, which is 3. Now, because I want x to the first power, I'm going to take that exponential, x to the negative 1/3, and I'm going to raise both sides to the reciprocal of that exponent. So the reciprocal of negative 1/3, negative 3. Now notice that I'm keeping the sign the same when I'm raising to the reciprocal exponent. The reciprocal of any fraction just means that I flip it over. I keep the sign the same. So because I raised the left side to the exponent of negative 3, I'm also going to raise the right side to the exponent of negative 3. So on the left side, x to the negative 1/3 raised to the negative third, I multiply those exponents together and I get x to the first power. On the right side, 3 to the negative third, yes, you could put that in your calculator to see what that value is, but you're going to get a really messy decimal, so you'll have to convert that back to a fraction. I find it easier to do it without the calculator. So a negative exponent means that I'm going to take the reciprocal. So I'm going to say 1 over 3 to the third power. So that tells me that my solution is x equals 1 over 27. Now in the last example we did the check by hand. This one, why don't we try our calculator? So I'm going to store 1 over 27 in the variable called x on my calculator. And then I'm going to go back to my original equation and I'm going to type 2x to the negative 1/3 into my calculator. And because my calculator knows that I've stored x equals 1 over 27, it's going to replace the x with 1 over 27 and do the correct calculations. When I do that check, I do see that the answer does turn out to be 6. So get used to checking these answers to make sure that you have calculated the exponents correctly. For exercise number 3, I see that there's a different process involved in getting the x by itself. So I still want to isolate the x, but this time I've got a 1 that's being added. So I want to subtract 1 from both sides of the equation. So I now have x to the 3/2 is equal to 9 minus 1, which is 8. Again, I want to get x to the first power, so that means I'm going to take x to the 3/2 and raise it to the reciprocal exponent. So I also raise 8 to the 2/3 power. Now again, something important to note is that this is an exponent. It's a power. I'm not multiplying 8 times 2/3. I'm raising 8 to the 2/3 power. So I end up with my solution, x equals, let's recall what it means to have an exponent that's a fraction. The denominator in the exponent tells me my root, so this is the cube root of 8 to the second. Again, I could use my calculator, but it's important that I understand what these exponents mean. So the cube root of 8 is 2. 2 to the second power is equal to 4. So my solution this time is x equals 4. If I go back and substitute that into my equation, I will find out that yes, that is indeed my solution. And again, you could use your calculator to do that check. Let's try exercise number 4 together. I want to get the variable by itself, so I'm going to first of all subtract 3 from both sides of the equation. So that's giving me 4x to the 2/3 is equal to 16. This is a two-step process to isolate the x, so now I need to divide both sides by 4. So I now have x to the 2/3 is equal to 16 divided by 4, which is 4. Now let's go ahead and raise both sides to the reciprocal exponent. So I'm going to raise both sides to the 3/2. So that gives me x to the first is equal to, this shows the square root of 4 to the 3rd power. So my solution for x, the square root of 4 is 2. 2 to the 3rd power is equal to 8. And again, I would go ahead and check that on my calculator. You can pause the video while you do that. For exercise number 5, we're going to solve this equation graphically. You'll notice that the equation has the same form as the previous examples that we've looked at, but we'd like to look at what the solution would look like on a graph. So when I have an equation like 2x to the 1/3 plus 5 equals 9, I'm going to do it first of all by hand, but then go ahead and put this in my graphing calculator as well. So I am going to look at the function that's on the left side. So y is equal to 2x to the 1/3 plus 5. I'm going to make a table of values for that function, and I'm going to graph that. Now I want to pick nice numbers for x that are going to give me coordinates that are easy to graph. So for example, if I pick 0 for x, 0 to the 1/3 power is 0. 2 times 0 plus 5 would give me an answer of 5. 1 is also a nice easy number, so let's use 1 for x. 1 to the 1/3 really just means I'm taking the cube root of 1. The cube root of 1 is 1. 2 times 1 is 2 plus 5 is 7. Now, when I think about the numbers that come next, 2, 3, 4, none of them are perfect cubes. So it would be difficult for me to find the exact value of the cube root of those numbers. And that's what I'm doing if I've got x to the 1/3 power. So what I'm going to do is think about the next number that is easy to take the cube root of. And I know that 8 is a perfect cube, so I'm going to use that number next for x. The cube root of 8 is 2. 2 times 2 is 4. 4 plus 5 is 9. So I have enough points that I can go ahead and graph this function. 0, 5 would be right about here. 1, 7. And then 8, 9. Now when I graph this, it's going to look like the following. And I could even check this on my graphing calculator to see that the graph matches up. I've got a little bit of a squiggly line there, but I think it'll be helpful to see where these cross. Now I look at the other side of my equation. The other side is equals 9. So I am going to make a new function called y equals 9. We of course know that that's a horizontal line through the y-axis at the number 9. Now if I look carefully, I see that actually they would cross at this point right here because both of them would have a y-coordinate of 9. So therefore, my x answer is going to be equal to 8. Now if I solve this algebraically as well, I could say, going back to my equation, 2x to the 1/3. If I subtract 5 from both sides of the equation, that would be equal to 4. If I divide both sides of the equation by 2, I'm getting x to the 1/3 is equal to 2. raise both sides to the reciprocal exponent. Hopefully you're getting used to this process by now. So this gives me x to the first is equal to 2 to the third power, which is 8. And I see that that algebraic solution matches the solution that I did on my graph. Now the other thing that you could do is put these functions into your graphing calculator. In y1, put 2x to the 1/3 plus 5. In y2, put y is equal to 9. And then use that intersect feature on our calculator. Remember that the intersect feature we get by doing the second and then the trace key. That's up along the bottom of the screen. In there we're going to choose option number 5, intersection. You have to move the cursor over close to the point of intersection by using the right or left arrow keys. Press enter 3 times, once for the first equation, once for the second equation, and once where it says guess. And then at the bottom of your screen, you should see this very same ordered pair that we just found was our point of intersection. Let's try 2 more examples together. So I'm going to, looking at the first example, I'm going to add 2 to both sides of the equation. So that gives me 2x to the 1/3 is equal to 6. Dividing both sides by 2, I've got x to the 1/3 is equal to 3. Let's raise both sides to the reciprocal exponent to get x to the first power. So I also raise the right side to the third. So my answer for x must be 27. And again, go back and check on your calculator. For number 2, we're going to add 5 to both sides of the equation, so x to the 4/3 is equal to 16. Let's raise both sides of the equation to the reciprocal exponent. We're going to have to think carefully when we're doing this exponent on the right side. So raising 16 to the 3/4 power, x to the first would be equal to, the 3/4 power really just means the 4th root of 16 to the third. So the 4th root of 16 is, of course, 2. 2 to the third is equal to 8. And again, if you're having a little trouble with these exponentials, you could also put this right in your calculator, 16 to the 3/4 power, and you'll see the result of 8. Try to practice on your own first before you go to the calculator. Now please go ahead and put the you try it's in your paper, in your notes. And I'd like you to give these 4 problems a try and then come back and check your solutions with mine. So pause the video so you can work on these problems. Hi folks, welcome back. Check your solutions with the work that I've done here and make sure that you match with answers. You'll notice that some of them turned out to be pretty big answers, so yes, I did need to use my calculator for that one to find 8 to the 5th power. And on number 2, this one worked out not to be a perfect cube, so therefore I'm going to leave it in cube root notation. In a future chapter, we're going to learn how to simplify the cube root of 16, but for right now, we're going to leave our answer just like that. If you have any questions about this process, please see me before class so that we can get it cleared up and be able to do some great work during class. We'll see you soon. Have a great night.